Part 1. Combined cycle power plant. Fundamental principle. In a combined cycle power plant, the primary function is energy conversion. Chemical energy from natural gas is transformed into thermal energy, then into mechanical energy, and finally into electrical energy. This process does not occur in a single step. Instead, the thermodynamic cycles operate sequentially. The first cycle is the gas turbine cycle. The process begins as natural gas enters the power plant. High-pressure gas is received at the entry station where it is filtered, heated, and pressure regulated. These steps ensure that the fuel is clean, dry, and stable before entering the turbine. The conditioned gas is then directed into the gas turbine. Inside the turbine, ambient air is drawn in and compressed. This compressed air is mixed with natural gas in the combustion system where controlled combustion takes place. The result is a high-temperature, high-pressure gas flow. As this gas expands through the turbine blades, it drives the turbine to rotate. The turbine is connected to a generator producing electricity. This stage is known as the Brayton cycle. However, the process does not end. The exhaust gases leaving the turbine still contain significant thermal energy instead of being released into the atmosphere. This energy is recovered. The second cycle begins here, the steam cycle. Exhaust gases are directed into the heat recovery steam generator, or HRSG. In this system, heat from the exhaust gas is transferred to water. The water is heated, boiled, and converted into high-pressure steam. This steam is then sent to the steam turbine. As the steam expands, it drives a second turbine connected to another generator. This results in additional electricity production. This process is known as the Rankine cycle. After passing through the turbine, the steam enters the condenser. Here it is cooled and converted back into liquid water. The water is then returned to the HRSG through the feed water system, completing a closed loop. The key advantage of a combined cycle system is efficiency. Energy that would normally be lost with exhaust gases is recovered and reused. As a result, overall efficiency is significantly increased. However, this efficiency depends on system balance. Instability in the gas system affects combustion. Combustion affects exhaust temperature, and exhaust temperature directly impacts generation. Any disruption in this chain reduces overall performance. For this reason, combined cycle power plants are not only energy systems but precisely balanced engineering systems.